Yeah, yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, right? Yeah, can anyone please confirm? So in the last session yesterday, right? Just briefing about big data, right? So types of data. So it provides two services, right? So three sources of data: social, machine, and transactional data. Types of data: structured, unstructured, and semi-structured. Hadoop is meant for storage and processing. It's meant for storage and processing. Hadoop is not for online processing. Hadoop is for batch applications, right? Batch applications means user non-interactive applications. User is no way required. Credit card statements for millions of customers. Drawbacks with the current databases. Drawbacks with the current databases, right? Yes. Limited storage, no parallel processing, volume increases speed, complexity increases speed, decreases, right? They can handle only structured data. They cannot handle unstructured or semi-structured data, right? Unlimited data storage. Very high speed processing because of parallel processing, very high speed processing. Can handle all varieties of data, structured, semi-structured, and unstructured, right? So open source, no licensing required. Yahoo, right, has taken a table of size 100 TB consisting of 1024 columns. Task is sorting based on 16 columns. Oracle has taken 3.5 days. MySQL has taken 6 days to process this. Teradata has taken 4.5 hours. Netezza has taken 3 hours. Hadoop has just taken 3.4 minutes, right? Yes. Just observe this, right? Yes. Okay. Now, why only Hadoop can? So before I go, right, just advantages of Hadoop. So unlimited data storage, right? Before I go with this, just I'll brief you. I'll just give you an overview of how this architecture of Hadoop, right? Later I discuss in brief storage and processing architecture during our right. Now, Hadoop architecture. Hadoop follows master slave architecture. Hadoop doesn't see here. Hadoop doesn't follow. Hadoop doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture. Master slave architecture. Hadoop doesn't follow client server architecture. It follows master slave architecture, right? Hadoop follows master slave architecture. Fine. What do you mean by Hadoop cluster? Hadoop cluster, right? Yes. Group of nodes. Group of nodes means CPUs. Connected in a network. Group of nodes, CPUs connected in a network. Hadoop cluster group of nodes, CPUs connected in a network. Group of nodes, CPUs connected in a network, right? There are two types of nodes. First one, master node and slave node. Master node, slave node. So in Hadoop terminology, we say like the name node, data node, right? Name node, data node. Okay, group of nodes connected in network. There are two types, master node and slave node. See, so this is master slave architecture. Hadoop follows single master and multiple slaves. Single master and multiple slaves, right? Yes, multiple slaves. Single master and multiple slaves. S1, S2, so on up to ESN. Master node and slave nodes. See, in a Hadoop, data is stored in the form of files. For example, f1.txt file. This file is divided. So this file, think that each system of 1 TB capacity, assume 1 TB, 1 TB, right? Yes. So, but f1.txt is 2 TB file, assume. But it cannot fit, it cannot be accommodated by any of the slave, right? So this file data is splitted into smaller parts, it's divided, splitted into smaller parts. Each part is stored across multiple slaves and are processed parallelly. Means this file is not stored in a single slave. It is divided into smaller parts. These parts are distributed across multiple slaves of multiple machines. These are stored across multiple slaves of multiple machines. And are processed parallelly. Two advantages you can see: distributed storage is possible and parallel processing is going to happen. So here, this master node responsibility, slave node responsibility, master node responsibilities, right? Yes. Master node responsibilities. Task assignment, assigning tasks to the slaves. Load balancing, right? Balancing the load on each and every slave. You need to assign the tasks equally to all the slaves. Load balancing. Fault tolerance, right? Yes, I'll come back. What do you mean by fault tolerance, right? Yes, fault tolerance. So task assignment, load balancing, fault tolerance. Okay. Fault tolerance means when multiple tasks are assigned. See, T1 tasks assigned to S1, T2 to S2, T3 to S3. When three tasks are assigned to three slaves, when three tasks are executed by three slaves parallelly, if any one slave goes down, then the task of it will be assigned to any of the run other slaves. This process we call like fault tolerance. Multiple tasks are executed by multiple slaves. If any slave goes down, then immediately the task will be assigned to any of the other slave. This process we call like fault tolerance mechanism, right? And health monitoring. Task assignment, load balancing, fault tolerance, health monitoring, right? Yes. Yes. And slave node responsibilities only two. Slave node responsibilities. First one, storing data and processing data. Storing the data. Second is like processing data. Okay. Hadoop follows master slave architecture, single node, single master and multiple slaves. So these are the master node responsibilities, slave node responsibilities. And Hadoop is proven in the market, right? Processing point of view, very high speed processing, whereas compared with other things, right? And here I was some query, right? Yes. Why databases? Why databases like Oracle? Oracle cannot support unlimited storage. Why databases like Oracle cannot support unlimited storage? Databases like Oracle cannot support unlimited storage, right? Yes. Why only Hadoop can means we have got some limitation on these databases, right? And database, observe here, databases and max limit on the number of slaves. Max limit on the number of slaves. Databases and max limit on the number of slaves. First one, like Oracle, right? Oracle can go max of 256. MySQL, right? Max it will go with 54 slaves. MySQL Express, 256 slaves. Oracle with 256, MySQL at 54, MySQL Express with 256 slaves. MySQL Express like 256 slaves, right? Yes. SQL Server, right? SQL Server, 256 nodes are slaves, right? Means CPUs. Yes. DB2 also, right? I will going with 256 slaves. And if you go to the specialized databases like Teradata, right? A specialized database like Teradata can go with 512 slaves, 512 CPUs. Netija, it can go with 512, right? It maximum it can go with 512 slaves. Vertica, max it can go with 512, right? But currently Teradata and Netija going with 1024, right? 1024 slaves. Yes. Teradata and Netija going with 1024 slaves. Yes, but none of these databases or specialized databases are supporting unlimited data, right? They have got limited storage. Even though Teradata Netija 1024 slaves, still we cannot say like unlimited storage, right? It's possible in that. So once they get filled, they cannot support data further, right? So, but there is no limitation. Observe, but there is no limitation. There is no limitation on the number of slaves, that Hadoop can have. There is no limitation on the number of slaves that Hadoop can have. Yes. Horizontally unlimited scalability, right? So for Hadoop, horizontally unlimited scalability. So Yahoo, when first time implemented Hadoop, went with Yahoo, when first time implemented Hadoop, went with 4,000 nodes, 4,000 slaves. Currently, Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop. Facebook, when first time implemented Hadoop, went with 8,000 slaves. 8,000 slaves for storing its data. Currently, Facebook going with 42,000, right? 42,000 slaves for storing its data. Yes, there is no limit on the number of slaves that Hadoop can have, right? Yes. It's proven in the market, storage point of view, and also processing point of view, right? It's proven in the market, right? Right. So now if I see the advantages, now once again, if you come back to these advantages, right? Unlimited data storage because of horizontally unlimited data storage because of horizontal. Because of horizontally unlimited scalability. We have got a feature, right? Unlimited data storage is how it's possible in Hadoop because of horizontally unlimited number of slaves can be added. Today, if you are running a business with less number of slaves, assume you are running the business with 10 slaves. If you're running the business with 10 slaves, right? Your business has increased, your branches have increased, customers are increased, data has increased. So you need to increase your number of slaves also, right? Horizontally, you keep on increasing. You will make 10 slaves to 100 slaves. Means if customers increased by 100 times, data increased by 1,000 times, you cannot go with the same number of systems or slaves, right? Horizontally, unlimited number of slaves can be added, right? That is the main feature, right? Unlimited data storage and very high speed processing, right? Because of parallel processing, data is divided into smaller parts, distributed across multiple systems, and are processed parallelly because of parallel processing. Parallel processing, right? Yes. Just I give a labor example, right? Parallel processing. For example, non-parallel and parallel. Just see the difference between non-parallel and parallel. One person preparing one item takes 1 minute. One person preparing one item takes 1 minute. One person preparing 10 items takes 10 minutes. The same one person preparing 100 items takes 100 minutes. The same one person preparing 1,000 items takes 1,000 minutes. Okay. Parallel processing, right? For one item, 1 minute. For 10 items, also 1 minute. For 100 items, also 1 minute. For 1,000 items, also 1 minute only, right? For all this, it takes 1 minute. For one person, 1 minute. One person for all this. Because here 10 persons preparing 10 items, 1 minute. 100 persons preparing 100 minutes, 100 items. 1,000 persons preparing 1,000 items takes 1 minute, right? So they are processing parallelly. They are processing parallelly, right? Yes. Okay. So that's what parallel and non-parallel, right? So very high speed processing because of and can handle all varieties of data, unstructured, semi-structured, and structured, right? Yes. Open source, no licensing required, and for Hadoop, it doesn't require like highly configured commodity hardware, we say. Commodity hardware, nothing but it doesn't require like highly configured, right? Any systems are okay, right? For working with installation of Hadoop, right? Yes. Fine. So Hadoop is providing the market storage point of view, processing point of view. That's why today like many projects are getting migrated to Hadoop and Spark environment, especially ETL kinds of projects are getting migrated towards Hadoop environment, Hadoop and Spark. Wherever there is a great boom, that wherever there is huge data, right? And how exactly data stored? How exactly data stored and processed? How exactly data stored and processed within Hadoop, right? Yes. How data stored and processed within. First, we see how exactly data stored in Hadoop. Data is stored in the form of files. In the form of files. Again, each file is subdivided right into blocks. Default block size equal to, previously it was 64 MB, currently default block size equal to 128 MB. Observe here, right? A1.txt. Okay, for example, how exactly data stored and processed? How exactly data stored and processed, right? Try to understand this diagram, right? I'll be discussing some cases. Yes. Case one. If the number of blocks equal to number of slaves, high speed, right? Full parallelism. Think that there are 4 blocks. Think that you have got 4 slaves, blocks B1, B2, B3, and B4. S1, S2, S3, S4. B1, B2, B3, B4 equal to S1, S2, S3, and S4. Number of blocks equal, okay. F1.txt, right? I got a file F1.txt of 230 MB, up to 230 MB. Default block size, assume the default block size 64 MB, assume. Number of blocks into how many blocks this file is divided, right? 230 by 64 means how many? 4 blocks. Each block consisting of 64, 64, 64, right? B1 block, B2 block, B3 block, and B4. B1 64, B2 64, B3 64, B4 38 MB. How these blocks are stored across the slaves? single master, multiple slaves. 1 2 3 4. 1 2 3 4. S1 S2 S3 S4. B1 here, B2 here, B3 here, and B4 here. B1 B2 B3 B4. F1.txt into 4 blocks. B1 B2 B3 and B4. B1 stored by S1, B2 stored by S2, B3 stored by slave 3, B4 by S4. B1, S3, S1, S2, S3, and S4. Fine. This is how exactly data stored. Now data processing, how the data processing is going to happen. So if we take any file, right, in Hadoop, in whatever size it is, here I have taken small file, divided into blocks. How many blocks? The blocks are distributed across slaves. Now data processing, data, right? The job is to process f1.txt. f1.txt divided into tasks, number of tasks. Number of tasks in Hadoop depends on number of unique blocks. Number of unique blocks. How many unique blocks? 4 unique blocks, right? 4 blocks. So 4 tasks. T1, T2, T3, and T4. Job is to process the file f1.txt divided into 4 tasks. T1, T2, T3, T4. T1 is for executing, right? B1 block, for T2 for executing B2, T3 for executing B3, T4 for executing B4. B1 for executing B1, T2 for B2, T3 for B3, T4 for B4. So here 4 tasks. T1, T2, T3, T4. 4 tasks are executed parallelly by 4 slaves. Four tasks are executed parallelly by 4 slaves, S1, S2, S3, S4. 4 tasks are executed parallelly by 4 slaves. Full parallelism, right? Full, no, none of the task is in waiting state. No, none of the task is in waiting state. All the tasks are executed by the slaves. Full parallelism. That is case 1. If number of blocks, right, is greater than number of slaves. Number of blocks means how many blocks? If number of blocks greater than number of slaves, how many blocks? Assume 4 blocks. Number of slaves only 2. B1, B2, B3, B4. B1, B2, B3, B4, and S1 and S2. Yes. Okay. F1.txt is the file. Size is like 230 MB, right? Into how many blocks? Default block size. Default block size means each block size is like 64 MB. Number of blocks is 230 by 4 blocks. 4 blocks means yes. B1 block, B2 block, B3 block, and B4 block. How these 4 blocks are stored across 2 slaves? S1 and S2. So B1 here, B2, B3 and B4. So here. and B3 and B4. B1 in S1, B2 in S2, B3 again in S1, B4 in S2. So data processing, right? That is data processing. Yes. Job to process f1.txt. Job is to process f1.txt. Number of tasks. Number of tasks always depends on number of unique blocks. Number of tasks equal to number of unique blocks. How many unique blocks? 4 blocks. Means 4 tasks. Job is to process f1.txt. T1, T2, T3, T4. T1 is for executing B1, T2 for B2, T3 for executing B3, T4 is executing B4. Right? B1 has got some data, B2, B3, B4. All right. So who should execute this T1 task? S1 only, right? No other. T2 by S2 only. This B2 is present in S2. B3 should be executed by S1. Again, B4 should be executed by S2. Means here, if you observe, slave 1 should execute 2 tasks, slave 2 should execute 2 tasks. Slave 1 should execute a T1 and a T3. Slave 2 should execute to T2 and T4. When T1 is executing, T3 will be in waiting state. Only one task will be executed. When T3 is executing, T4 will be in waiting state. So once this T1 execution finished, next T3 executes. This means here 2 tasks are in the waiting state. If you take 40 tasks, 20 tasks will be in the waiting state. Means here less speed, right? Less parallelism. If the number of blocks are more, less speed. Right? And if you observe this case 3, right? Case 3. More blocks, only one slave. Assume there is only one slave. Only one slave. Okay. Assume this is that only one slave. So here B1 block here, B2 block here, B3 block here, B4, all blocks are stored. So f1.txt divided into 4 blocks, B1, B2, B3, and B4, right there. B1 stored in slave 1 only, B2 into slave 1, B3 also in slave 1, B4 also in slave 1. All the data is stored in slave 1 only. And if we talk about the data processing, number of tasks, number of unique blocks. Number of unique blocks, how many? 4. 4 blocks means 4 tasks. T1, T2, T3, and T4. And job is to process f1.txt into 4 tasks. T1, T2, T3, T4. T1 for executing B1, T2 for executing B2, T3 for B3, and T4 for B4. Who should execute all this? Slave 1 only should execute, right? One after the other, sequentially, right? Yes. If 1 person, 4 persons 4 tasks, full parallelism. If each task taking 1 hour means 4 tasks completes in 1 hour. If 4 persons, 4 labors, 2 persons, but 4 tasks. The first person 2 tasks, second person takes 2 hours. Only 1 person, 4 tasks, one after the other sequentially, 4 hours. So more slaves, more speed. Less slaves, less speed. If only one slave, no parallel processing at all, right? So depends upon the slaves. And you may get one query, right? Yes. Here, when T1 task to slave 1, T2 to S2, T3 task to slave 3, T4 to S2. When 4 tasks are executed by the 4 slaves parallelly, suddenly if any slave goes down, executed by the 4 slaves parallelly, right? Okay, fine. Okay, so while executing 4 tasks by the 4 slaves, if any one slave goes down, then the data V2 block is lost, the data is lost, and T2 task is failed. T2 task is failed. So for that, how Hadoop is able to overcome these kind of things? 2 things you can see here, data is lost and task is failed. So for that, we have got a concept called fault tolerance and replication, right? Yes. We have got powerful fault tolerance model and replication for fault tolerance and replication in Hadoop. So fault tolerance and replication. So here replications means duplication. Replication means duplication, right? Replication is nothing but duplication. Default number of replications in Hadoop equal to 3. Means just understand this, how this Hadoop is able to overcome this situation means, if I got a file f1.txt 192 MB, you think into how many blocks it is divided? 192 by 64, right? Exactly, you will get 3 blocks, B1, B2, and B3. Here replicate B1 duplicated by 3 times, B2 by 3 times, B3 by 3 times, means totally 9 blocks you will get. How these 9 blocks are stored across these 3 slaves? How they are stored across these 3 slaves? Slave 1, slave 2, slave 3. B1 here, B2 here, B3 here. Again B1, B3, B2. B3, B1, B2. So here f1.txt into 3 blocks, B1, B2, and B3. B1 stored in S1, S2, and S3. B2 also in S1, S2, and S3. S2 and S3. S1, S2, S3, S1, S2, S3. Data processing. Job to process f1.txt always divided into number of tasks. Job always divides into tasks. Number of tasks equal to number of unique blocks. How many unique blocks? 4, sorry, 3. 3 unique blocks, not unique block. It's not 9. They are duplicated blocks. Job is to process f1.txt. Right. T1, T2, and T3. T1 for executing B1, T2 for executing B2, T3 for executing B3. Who should execute T1? S1 can execute, S2 can execute, S3. Because B1 block is present in S1, S2, S3. T3, S1, S2, and S3. Assume for executing T1, S1 only selected. For T2, S2 only selected. For T3, S3 only selected. So T1 by S1. If suddenly this, when executing these 3 tasks, suddenly if a slave goes down, still there is no data loss. Still B1, B2, B3 available in S1, S2, still if S1 also down, still data is there in S3, right? So Hadoop is going to follow this mechanism, right? We call this as replications, duplications. And suddenly if any task failed, the task is going to be assigned to any of the other slave. This mechanism is called as fault tolerance mechanism, right? So, right, how exactly data storage is processing is happening. So I'll brief you more on this Hadoop architecture. I'll be discussing in the next week, right? Hadoop architecture, Hadoop storage architecture and processing architecture, storage components and processing components, and also about yarn, yet another resource negotiator. So from next week onwards, we will go with 2 hours, 2 hours, 2 hours on Saturday, 2 hours on Sunday, right? Yes, 4 to 6, 4 to 6. Right? Okay. So get enrolled, get registered, right? Everyone try to get enrolled and get registered, right? In this course. So the payment details and procedures, everything is given in this chart panel. And just click this. It's an offer batch. Both Hadoop and Spark is discussed. Right? You'll be getting the recorded videos, soft copy of the notes. Right. Any queries from your side? Yes. So my mostly my discussion will be, my more concentration will be on PySpark, right? What we have discussed yesterday. Fine. Any queries?
Yeah, hi sir. Good afternoon, sir. Sakshi this side. Sir, I'm having the questions as in saying that in the weekend we are, it means we have only the 4 lectures now. It means 4 hours.
Yes.
So, sir, it's possible to cover up all the syllabus in the
So when I start with the practicals, I will increase the duration, right? So when I go with the practical parts, right? Not like exactly I'll be increasing, I'll be going with 3 hours sometimes, I'll be taking 4 hours also, pre-intimating before, right?
Okay.
Fine.
Yeah, and also, sir, I'm having the one more small doubts. It means here in this course, can you cover the interview perspective questions also?
Yes, yes.
Because currently I'm working only in the big data, but not completely big data.
Yeah, okay. Fine, that's not, as I can provide the interview questions, right? And during this topics only, I'll be providing you the questions, right? Many different questions.
Okay, so yeah, thank you, sir.
Fine. Okay, so get enrolled to this course. Next Saturday, the link is going to be changed, right? Those who got enrolled, you'll be getting the link to your mail IDs. Don't forget, if you're done with the payment process, don't forget to send your screenshot of your payment to this mail ID provided in the message. DURGASOFT online training @gmail.com, right? Fine. So I'm stopping for now. So we'll continue next Saturday, right? At 4 p.m. More discussion on this, right? Yes. Fine.
Thank you, sir.